Section 5.2, functions. All right, a couple of definitions. A relation. A relation is a set of ordered pairs. Any old set of ordered pairs. A function, however, is a special relation. A function is a relation where each input has exactly one output. All right, so a lot of times we write ordered pairs here in a table. So I'm going to give you a couple relations, and we are going to decide if they are functions or not. So let's see, I guess I'll go with 3 of them. Okay, there's the first one. Clearly a relation, got ordered pairs, it's got the ordered pair 1, negative 2, 2, 3, so on and so forth. Is it a function? Well, it's pretty easy to tell if it's a function. I look at the inputs. I have 1, 2, 3, 4. No inputs repeat, and every input given has an output. So that one's a function. All right, let's look at something here that's not a function. How about if I gave you so this first one here, this was a function. The second one, however, is not a function. Why not? Well, look at your inputs, and what I see is I see an input value that repeats. This input value has 2 different outputs. That makes it not a function. Basically, when you're talking about a function, you're looking at the inputs, and you're making sure the inputs do not repeat. Last one. Is that one a function? Well, this is where it gets a little confusing. Many students originally, when they look at this, will tell me, no, it's not a function because the number 3 repeats over here. That's okay. The rule for a function is each input has one output. So really what you're looking for when you're looking at functions is you're looking at the inputs. Does any input repeat? Your answer is no. I got 1, I got 2, I got 3, I got 4. I got 4 different inputs. None of them repeat. This one is a function. All right, now for most of the things we're going to look at in this course, functions are going to come either as graphs or they're going to come as equations. So let's talk about equations first, I guess. How about if I were to give you an equation, y equals x minus 2? Is that a function? Well, probably the easiest way to determine if a equation is a function is to build a little table and see. Pick some inputs. I'm going to pick a couple, 0, 3, negative 2. Good rule of thumb is to pick one positive, one negative, and 0. When I plug a number in for x, how many answers do I get? If I plug in 0 for x, y would be 0 minus 2 is negative 2. I get one answer. If I plug in 3 for x, I get 3 minus 2. That's 1. If I plug in negative 2, I get negative 2 minus 2. That's negative 4. So we notice that no matter what number I plug in for x, I'm only going to get one unique answer for y. So yeah, this one is a function. Give you a slightly different one though. Oops, that's all right. Still, I'll go with y squared equals x. Again, I would pick a couple of numbers here. If I plug in 0, I end up with, plug in x for 0, I get y squared equals 0. So y would be 0. That's fine. So far we're looking at this one and we're thinking, yeah, this one is a function. This is why it's important to plug in more than one number. If I plug in 4, I get y squared equals 4. Y could equal 2, or y could equal negative 2. Because negative 2 times negative 2, after all, is 4 also. So right there, I've got a problem. The number 4 has 2 outputs. It's got 2 and it's got negative 2. So that one's not a function. Okay. Now, for most of this course, we have been looking at an important type of function. We just didn't call it that. A linear function. Any line, as long as it's not a vertical line, is a function. y equals mx plus b. So any equation that can be written in the form y equals mx plus b, you're guaranteed that that's a function. All right, well, the last way we look at functions is we look at graphs. And when we look at a graph, we have a rule called the vertical line test. The vertical line test says if any vertical line crosses a graph more than once, then the graph, oh boy, I didn't write that very well, then the graph is not a function. All right, so let me draw you some pictures here. So here's a function. Why is that a function? Well, it's a function because your answer will be it passes the vertical line test. So if I ask you, is this a function? You will say yes, function, and then you will say passes vertical line test. Okay? And so think about it. No matter where I draw a vertical line, I can draw lots of them here, any vertical line I draw only crosses that graph more than once. On the other hand, look at this picture. This one is not a function because it fails the vertical line test. And you can abbreviate vertical line test as VLT, just as I did. Well, what's the problem here? Well, the problem here is I can draw a vertical line and it crosses twice. Why does that make this not a function? Well, I haven't given you scaling on this graph, but I'm going to tell you what these 2 points are. This point right here is 3, 1, and this point right here is 3, 2. So notice what happens. I have an x value, the number 3, which has 2 outputs. That makes it not a function. Okay, the last thing we need to talk about in this section is domain and range. Domain is all inputs, basically x values, and range is all outputs, y values. And I'm going to go over to my computer here. I've got some pictures that we're going to look at, and we will determine the domain and range of those pictures. All right, so let's take a look at these pictures here. We're looking for the domain and the range. Domain means the x values. Range means the y values. So what you got to do is you got to look at your picture. Domain. This graph has a dot right here, which means this graph stops here. So our smallest x value would be -2. And the graph goes towards the right, keeps going, and again, there's a dot right there, which tells me the graph stops there. It doesn't go on forever. It goes up until it looks like x equals 3. So our domain, we would come here, and use the equation editor in Word to type this in. Our smallest x value was -2. So -2 is less than or equal to x, less than or equal to 3. That was our biggest x value. Range, on the other hand, means our y values. So let's look at the range here. The lowest point on this graph is right here. Y is 0. And the highest point on this graph goes up till it gets to here, which is 9. All right, so insert another equation. So our lowest y value was 0. So 0 is less than or equal to y, less than or equal to 9, we decided. So there's our domain and range for that picture. Number 2. All right, notice a difference on this one. A difference on this one has arrows, which means this graph continues forever. So this graph continues forever down to the left, and it also continues forever down to the right. So this graph I just said goes forever to the left, forever to the right. That means we use every x number. But a real common mistake I'll see students say is I'll have them say domain goes from -4 to 4. Well, that's only what you see in the picture. But these arrows tell you the graph goes forever. So this graph really keeps going down and out and down and out. My domain is all real numbers. Graph goes forever to the left, forever to the right. Range, on the other hand, our lowest y value, we go down forever. We go down to negative infinity. And our highest y value is 4. So the easiest way to write that, I think, I would just write y can be any number as long as it's less than or equal to 4. See the difference between those two? First two that I did, the first one had dots on it, which means the graph stops. It doesn't go forever. This one, however, has arrows, which means it goes forever. All right, so the last one, I think, is actually the easiest of the three. There's an arrow on this end, which means the graph goes up and left forever. So it goes forever and ever and ever. And an arrow on this one goes down and right forever and ever. So the graph goes left forever, graph goes right forever. Our domain is all real numbers. At the same time, I just said the graph goes to the left forever. I'm sorry, the graph goes up forever on the left, the graph goes down forever on the right. So again, I'm hitting all the numbers. Oops, my range is also all real numbers.